Hello, this is going to be a brief video tutorial overview of setting up this acoustic Doppler current profiler that we have here to the laptop and testing all the equipment to make sure that it works. Ideally, we would also repeat this process by the river when we're making a measurement as well. But today I'll just demonstrate the different components we'll be using. So we have the acoustic Doppler current profiler, and we see the 4 transducer faces there, and these are the surfaces that we really want to be very careful not to scratch or damage or drop in any way. So it comes with this yellow protective covering, which we will use, and I'll cover that back up and gently turn it on its side here. So on the bottom here, we have our 12-volt battery cable, which comes with a covering on it as well. And we're going to use that to hook up to this connector cable so that we can connect the ADCP unit to the battery as well as our laptop. And so one thing to note is this cable goes one direction, and so it can't be flipped either side. You have to line it up, and I like to look at this face here, which is a bit lower, so I'll match it up with that. And you want this connection to be pretty tight, so we want it to be more or less all the way flush with this. So I'll keep jimmying that forward, but this is especially important in the field so that we don't lose connection here. Now that we have the cable mostly all the way connected there, could still get it a few more millimeters. We're gonna go ahead and open up the laptop. And I wanted to walk through this figure. Doesn't have any particular sign-in information, and I've made sure to port over relevant ADCP software. And so that will include our BBTalk, which is how we'll connect to the ADCP machine itself, as well as this WinRiver 2, which is the Teledyne software used to run a transect. In addition to these two software, we also have QRev installed to process ADCP measurements and check to make sure everything looks good there. And so we've connected this cable, but we need to supply power as well as actually connect the ADCP to the computer itself. And so for the power cable, we'll want to hook up the black end to the black terminal and the red to the red terminal, making sure not to cross wires. It also comes with this cable in case it's a different battery connection than that. And for connecting the ADCP to the computer, we'll use this terminal here connected to this connector cable. And so that will look like connecting these two here. Oops. And we'll also want to screw in the ends as well to secure it. All right, so now we have this secured here, and the blue light is on, indicating that we've made a connection, and we also have connected this cable into the computer. And so now to sort out where our ADCP is connected, we're going to open up the BBTalk application, and we'll attempt to connect to our workhorse device. And first we'll try COM port 3, and we'll keep the connection preferences set there and keep that command as well. And we're gonna look at the properties tab here and attempt to auto detect our ADCP in this COM3 port. And so it is now checking different baud rates to determine, how the ADCP is connected, so that we can send commands from this computer to the acoustic Doppler current profiler. Okay, and so we could not detect the ADCP on this COM port, so we're going to go ahead and try a new connection, and this time we'll try COM5. And we'll look at our properties tab again and auto detect the ADCP. And again, it's going to check different baud rates, and we'll see some commands pop up there, and it says ADCP connected, which is great. And we can look here at what the baud rate was that was chosen. So it was that 115,200 with no parity and one stop bit. And so now our ADCP is connected, and we see this light come on here to indicate some connection there. So we're going to go ahead and open up our WinRiver software now, so that we can set up a new ADCP measurement. So to do that, we'll go File, New Measurement, and we'll enter a station name. Here I'm just going to enter test and a station number. So if there's a specific number we're affiliating with a location or a river name, for example, Yakupa, and then we can put other information such as agency, country, state, county. I'll leave these blank for now, but in the field it's really important to populate as much data as we can so that it's easy for others to read and understand our measurements. We also want to set the date of the measurement as well as the number. The field party would be who's collecting the data, and similarly processed is who's ending up processing that data. There's different options for deployment type. So a manned boat would be someone's driving a boat. A tethered boat would be you're pulling the ADCP in its own boat. Remote control would be a remote control boat, and then cableway would be sending the ADCP back and forth through a cable. In this case, we'll keep it as the default of manned boat, but obviously we are not in a river environment, and so this is just a fake example. And in fact, I'll include other there. So now we'll scroll down, and feel free to add any remarks like, this is where we're measuring the river, upstream or downstream of the bridge. The more information you can populate here, the better. So now we'll go next, and this is helping to determine the rating information. And so if there's a gauge height reading at a nearby station, that would be great to include here. And another thing we like to note down is the water temperature as well. The ADCP has its own temperature sensor, which is needed to read inaccurately the speed of the water. And so by comparing it with a known water temperature, it's helpful to ensure that the machine is working as expected. Okay, so now it says interrogating the ADCP, please wait. And so we have a green light, which indicates that we are connected. If it doesn't show up as connected, we can also try to set the device based on the known COM port from that BBTalk software. And so that BBTalk software is really helpful for making sure that we're effectively connected at this stage. The transducer offset is very important to set, and so this is going to be the height that the transducer sits in the water from the surface of the water. And so if this ADCP is connected to a floating boat in the water that sits there, we'll want to measure with high precision, how deep the furthest end of the transducer is to the top. And obviously in the water, we're going to want to remove this covering so that we can actually get readings from the transducer faces. And so that's the transducer depth, and it's set to meters. And something else that's important that we want to set is the max water depth here, because that will help determine the settings on it. And so currently it's set to 5 meters, but if we're in a shallower channel, we'll want to adjust that as needed. Okay, so we'll leave that configuration in there for now. And then we're gonna set up the station name, and this is basically how we'll save the file. And so this will be station with, you know, for example, if we were at the QRev near a specific bridge or location, we'd want to give it a more informative file name. We can also append the date and time to the file name, which I recommend so that it's really easy to track when measurements were recorded. And currently it's set up to save in this measurements file under the C directory, but that could be adjusted as needed as well. Okay, so that has already been saved. So I'll set this as transect number 1. Oops. Okay. And I'll do no date for this particular fake measurement. Okay, so here's the preview of the commands that the computer will send to the ADCP. Typically I would not worry about changing any of these here, but more documentation can be found if any of those need to be updated. Okay, so now we see, you know, the serial number. We're working with a Rio Grande ADCP, and we are not currently set up with GPS or a depth sounder. And to estimate discharge, we're using a power curve estimate. And then this transducer depth would need to be changed in the field, as well as max water depth and the other aspects I mentioned. Okay, so now we've set up our measurement, and we're going to want to do first some ADCP tests. So first we'll want to execute an ADCP test. And this will just check to make sure that the ADCP is working as expected. So it's very important to run this test before every single measurement and just make sure that, you know, all the beams are working as expected. And so we'll see these different pass signs, which are important to know that the machine is working like we expect it to. Okay, so in addition to the ADCP test, we're also going to want to do a compass calibration before every measurement. So for the compass calibration, we're going to want to slowly rotate our ADCP sensor to make sure that the compass is calibrated. And again, this test is needed for each new measurement, and is an important step that's needed to make sure that the ADCP kind of knows where it is in order to compute the velocity field accurately. And so for this, we're actually going to turn over the ADCP sensor just for my demonstration on land here, but in the water, we're going to want to have this set up in its configuration, or you can also stand up with the ADCP locked into its boat and slowly rotate it. And so we're going to go ahead and press calibrate to set up a new calibration. And we're going to default to the start calibration procedure here. And once we're ready, we can press the space bar to start taking data after the instrument is set up. And for this, we can see there's, you know, north direction at the start, And so we're just going to slowly rotate the compass, and we'll see that it'll start populating the different directions there. And we'll want to do this really, really slowly, and so just a gentle rotation of the sensor itself. And again, this is just a land demonstration. You know, ideally we would have the sensor pointed in the same direction, so down, as we would when we're going to take the measurement. And so we're starting to slowly populate the different directions, and we'll continue on. And again, this calibration should take about 2 minutes, and so really go nice and slow and take your time as you rotate, and try not to wiggle the sensor too much, because you can get too high pitch and roll errors. And so if it goes above 3 degrees, it won't work well. So we're almost getting there, but again, we want to be really patient and make sure that the sensor's in every direction for a specified amount of time. So just slowly rotating it until we've completed our circle. Okay, so now we see calculating compass performance, and we can get, we want to see this symbol or this text, successfully evaluated compass performance for the current calibration. Then we can press the space bar to continue. And then we're all set, and we have our compass calibration. And again, this compass calibration is very critical, especially for wanting to do a moving bed test. And so next we will also want to set our ADCP clock, and it will default to the PC time. And so definitely feel free to update this time setting to East Africa time or whatever time zone the ADCP is being measured in. And we can do that through adjusting the date and time there and specifying the specific time zone. We will also want to initiate a moving bed test as well. And so we'll want to start pinging, which we can do by acquire start pinging or press F4. And it will start programming the instrument. And again, because this is not in the water, it won't actually be picking up any signal, but we will hear this chirping so that we know that it's working and connected. And now that we're pinging, we can select a moving bed test, and a loop test requires compass calibration, but most likely we'll want to do a stationary test. And basically what this looks like is we have the ADCP in one location for 10 minutes. We're going to go ahead and stop the moving bed test for now because we're not actually in the water, but that's also recommended before each one. And so here we see, you know, the percentage of bad bottom track values exceeds 20. This test is not accurate, try another test. But hopefully in the water it will actually be picking up actual measurements there. Okay, so now that we've kind of briefly gone over a moving bed test, we're going to go ahead and move through the motions of actually starting a discharge measurement transect. And so that command is going to be F5 or acquire start transect. And we're going to want to estimate the distance from the shore. It's unlikely we'll be able to get the ADCP sensor all the way towards the edge of the bank, and so it's important to accurately measure this distance from the shore, you know, either with a tape measure or if it's far away with a distance reader of sorts. Here we'll just say 1 meters because we're not actually making a measurement. And then we also want to specify whether we're at the left bank or the right bank. And this will be kind of facing with the direction of the flow of the river. And so the left bank would be the left side of looking downstream, etc. And so we'll set the edge measurement, and then we'll want to make sure that we have at least a specific number of good measurements at the edge. And then once we've gone from the left side to the right side of the river, we'll go ahead and end the transect. And again, we'll want to measure the distance from the shore. Here we'll specify 1 meter. And then we'll want to make sure, you know, before we end the transect that we've sat on the right side for, again, at least 10 ensembles as well. And then we'll press OK. And now that we've made 1 transect, we're going to go ahead and go again from right to left and repeat that at least twice. So we want at least 4 transects in any given river measurement. We want the measurement time to be at least 10 minutes, I believe. And so we might have to go back and forth 5 or 6 times if the river is not super wide. And so that's kind of the basics of setting up a measurement. It's a bit challenging because we didn't actually, we're not actually in the river here. And then once we're done, it's important to stop pinging, and then it'll stop beeping. And now I wanted to go ahead and open up an actual discharge measurement to kind of see what that looks like so that we know what to expect. And we're gonna go ahead and open up our documents, and we have an ADCP folder there where we have some of these discharge measurements. Let's see if that is able to open. Okay, great. So now we're actually seeing what the data should look like. So things we want to check for are that the beams are in relative alignment with each other, and that the ship track is fairly smooth from left to right. And so we want, you know, the direction of these blue lines to be more or less aligned with each other and not crossing. And then we also want to see that these ensembles are pretty filled in. And so if there's big white gaps in the measurement, that's a sign that it wasn't a very good transect. We also want to know, for example, some of these QA/QC parameters as well. And so we can hopefully kind of see similar alignment for measurements that are taken in the field. And this is an example of a river where it was really shallow in the middle, and we have a deeper section over here, and some gaps as well. And then it's colored by the Earth velocity magnitude reference. So higher values are closer to red and lower values are in this purple there. So this is an example of what we would expect to see in the water as we go to make a transect. And it's important too to set the depth accurately, so that we can know kind of how to set up the ADCP in those commands as well. Finally, I wanted to demonstrate evaluating our discharge measurements and saving them within the QRev software. And this software helps to determine, what challenges there might have been with the measurements, and also can prompt us to make sure that we're, for example, performing a moving bed test, how our GPS and depth look, and if there's any settings we want to change or transects that we don't want to include. And so I'm going to go ahead to this ADCP folder and look for this measurement that was taken by Heather Best on MI3. And we're just going to load the checked transects. But we could also include all of them if we wanted to as well. And so here we have some transects loading up, and we have a right transect and a left transect on this river. And then we can see the track as well as the user rating performed there. And we can go through and look at the system test. Did we perform a system test? Did it pass? We can look to see whether there was a compass calibration performed and what the results of that were. We can look and see, the temperature and salinity, and if that was consistent between the different transects. And then if we computed an independent value to see how that lines up. The moving bed test is also important to include, and so in this case a loop test was performed, and in this case the loop test was not an accurate one, but it's important to include this within this measurement file. We can also look to see, was the Bluetooth connection stable. For some ADCPs we use Bluetooth. In this case we have a hardwired connection there. GPS will likely show up as red if GPS was not used. So in this case we have 100% invalid GPS because it was not used for that measurement. We also want to look at the depth of the different beams and the extent to which they were valid, as well as the number of cells and how data were extrapolated. And so, for example, if we extrapolate to the edges, that can be a challenge there. And so for the edges, here we have a left distance of 0. And so that should probably not necessarily be 0, but be closer to 0.5, for example, because often we can't start exactly at the edge. And then we also want to make sure that we have a correct number of valid pings at each given edge measurement. And so here are edge measurements there. And finally, we can look at advanced graphs as well. And so once all that is complete, we can kind of look at what our estimated discharge is there. And so we have the total discharge between the two transects is 81 and 80.9, which is in pretty close agreement. So we feel pretty confident that in this case, the total discharge was 80.975 approximately. So this is just an example of how we can use this tool to evaluate it. We can also save these data, and we have estimated QRev uncertainty from the measurement. We can save it as a QRev file there and then open it up in the future, which is great. This can also connect to Google Earth Engine, where we can then see these transects plotted there, especially if GPS was included. And that's a quick overview of QRev, but there are a lot of different documentation, and so I've also linked here for reference. We have in this ADCP file USGS ADCP best practices, as well as a document on measuring discharge from a moving boat that goes into in-depth documentation on best practices and how this is performed. And so here's an overview of the procedures and best practices that goes through the preparation, site selection, moving bed tests, collecting transects, and processing the measurements. And so, for example, here I've done an overview of office preparation, so just making sure that the serial ports are working and that the connections are there. But then in the field, we'll want to go through a lot of this again and make sure we're selecting good sites for our measurements as well. And so I really recommend reading through this documentation, which is on the computer already, and reaching out to me if there's any questions or concerns. And you all have my WhatsApp, and yeah, best of luck. And yeah, wish I could be there with you all to measure some of these rivers.